Hey everyone, my name is Amara Graham. I see we've got some people joining. Fantastic. Good morning, good evening, good afternoon, wherever you are. Hopefully you're here ready to join us for our WebRTC developer tutorial. This is a bit of a follow-on to the one that we previously did. That was more of what we were describing as 101 level topics. So we will not go through all of the information that we covered last time. We simply just don't have enough time. So if you're interested in that, we did record it. It is available to watch, but consider this kind of the follow-on to that previous WebRTC developer tutorial webinar. We've got a poll running. So as you're joining, if you could take a couple seconds to fill that out, answer just a couple of questions about what you're currently doing with live video streaming, if you're doing something with live video streaming, and what kind of latency do you see in your stream? Additionally, we have the Q&A panel where you can go ahead and ask questions. We'll be answering those throughout the webinar, both on the chat as well as in on the conversation that we're having, that chat, as well as within the Q&A panel itself. So if we don't get to all of your questions or we don't actively talk about all of your questions, we will still try to get those answered. All right. So moving along here, just a quick agenda. Like I mentioned, that this is a bit of a follow-on to our previous session. So we're going to kick it off with just a brief overview of WebRTC so we can level set on where we're at and some intros. From there, we're going to start talking about getting started with building or customizing your own publish and play experience. This is something that was asked during our last webinar. We do have examples that are available to kind of play around with and tweak. We'll go over those as well as some simplified examples. From there, we're going to talk about signaling and considerations for security for your WebRTC workflow. So this is along the lines of productionalizing your WebRTC workflow, making sure that it is safe and secure for your customers or your users. And then finally, we're going to talk a little bit about UDP and TCP and why we recommend UDP. So again, this isn't super beginner level topics. If you're interested in watching that 101 level content, we do have recordings available for you to watch. And if this is too over your head, that's totally okay. Like I said, this is definitely a follow-on to that previous discussion. So we're going to cover about 45 minutes of presentation. Like I said, we're going to take Q&A throughout. We will try to answer your questions as they come up. And we also have other folks watching from our support team that will also be able to help answer questions. So with that, again, my name is Amara Graham. I'll be moderating today. I'm the Director of Developer Relations here at Wowza. Joining me today, I have Frank and Drew, both engineers working very closely with WebRTC, both on the server side and the client side. And yeah, hopefully we'll have a great webinar for you today. So let's go ahead and dive right into our content. Like I said, I wanted to kind of level set and just address what is WebRTC quickly, and then we'll dive into kind of our more in-depth content. So Frank, you want to talk to me a little bit about what is WebRTC and what are the considerations? Why WebRTC now?
Okay, so in general, what is WebRTC? It is, a browser-based communications solution. Everything's built off of open standards to include the information about how media is actually sent, how you can exchange or set up connections to send media, and even to interact with different browsers' APIs to create and control WebRTC connections or sessions. It does look like a kind of a great direct replacement for a plugin based architecture like Flash, which we all know is turned off or being turned off almost everywhere. WebRTC in general does require a media server or a CDN to scale to large audiences. And that is something we will get into a little bit more in the next slide. But basically, the scalability of the WebRTC solution provided by default, which is based off of peer-to-peer connections, doesn't scale well without having media servers or a CDN to do that.
Yeah, so moving to the next slide, let's talk a little bit more about WebRTC with Wowza specifically. So Frank, I know there was points that you wanted to touch on here, like you did in the last webinar, but talk us through some of the benefits, the limitations, what you really see with WebRTC and Wowza, especially with Wowza streaming engine.
Yeah, one of the big benefits, I think, is that it's a free and open source protocol. You know, that kind of expands the opportunities for different clients to implement the standard themselves, which allows for, you know, greater interoperability with more devices. That's good. As a focus on some open source or, you know, royalty-free codecs, which eliminates issues around patent encumbrance or use licensing with certain encoding formats. It's obviously super fast. It's focused on real-time communication. So the encoders you'll typically use used with WebRTC will be tuned to minimize latency. And just as we stated before, the limitations are designed for small group video conferencing and doesn't scale on its own. And with Wowza streaming engine in particular, I would think that it's worth noting that most of our capabilities and enhancements that we bring to the table are focused on publishing workflows. So one-to-many, few-to-many type workflows are kind of the bread and butter for Wowza streaming engine in general, and certainly WebRTC.
It's a great segue into the next slide. It's like you've seen them or something. So we like to show supported Wowza and WebRTC use cases to folks. I know WebRTC in particular is very attractive right now for low, near real-time latency. But you know, that's not all that it can do. And we like to highlight some of the additional ways that you can think about using WebRTC with Wowza. So Frank, I don't know if there's any in particular that you wanted to call out. I know I wanted to mention the first one, WebRTC to HLS, available with Wowza Streaming Engine and Wowza Streaming Cloud. An interesting way to look at kind of this COVID era that we're in right now, where people are looking to broadcast straight from a browser and straight from a webcam. And this gives you an interesting way to go about doing that while still using HLS and getting that ability to scale out. So that's the one that I wanted to call out on this list. Is there anything, Frank, that you wanted to touch on or anything that you wanted to talk through?
Not in particular. I think that covers most of it. The bottom four are certainly the lower latency end-to-end solutions that we provide. And you covered the first.
Cool. So from here, I'm going to hand it over to Drew, and he's going to talk us through kind of the coding aspects of both publish and play. So I'm going to stop sharing, Drew, if you want to take it from here, or do you want me to leave this slide up and you want to talk through it quick?
No, I'll go ahead and start sharing.
Okay.
Cool. So basically what we've put together is kind of a few different tiers of examples that everybody can use to see how one might publish to Wowza streaming engine with WebRTC or play back from it. In this GitHub repo we have, that the link will be in the slide set, we basically have a full kitchen sink setup that you can clone this repo, and then there's documentation on how to set it up and get it running locally on your system. We also have these two publish and playback demo pages up, and the links are available in the slides for those as well. But it allows you to publish to a Wowza streaming engine instance and You know, select your camera, there's a screen share demo, you can set your frame rate and all that. None of that's really required for WebRTC publishing. If you leave that information out when the user media is collected from the browser, it'll kind of fill that in as a best guess. But this is just kind of our version to show you everything you can do. And in this repo, there's basically all the files that you're seeing make this work. So you can go in and rip stuff out, you can add stuff, you can tweak it and play with it as much as you want. We also have one for playback. It's a little more simple, but we can see if I click publish on this, that starts running. And then just looking at my engine instance, there's the incoming demo stream. So right now I should be able to play back on here. And the demo gods have smiled on me today. Since I'm running a Zoom sharing my screen, the quality is not what we'd hope, but it works pretty well when that's all you're doing.
Yeah, I guess that's what we should have mentioned at the beginning of this, that any demo you see here is going to be pressed with our machines running Zoom, potentially Engine locally, maybe even Slack, an email client, and all sorts of other stuff, which is not really a production like
that. And we also have some tuning suggestions you can make for your streaming engine instance, so that'll perform better. And obviously you're going to want that on a dedicated machine, not what you're doing your day-to-day work on. So a couple cool things that we just came up with this week is, I don't know if we're live yet with it, Amara, but we will be soon. We have a code pen, kind of a stripped down version of this. So if you want to go in, you can actually modify the code in line with the constraints. You can put your application stream and WSS URL directly into that, and then run it from your browser. Boom. So that's publishing. We can see, should be a new stream coming on here soon. Uh-oh.
If I just messed you up, oh no, I was gonna say, if I just messed you up, it's because I just set both of those pens to public.
Oh, that'd be funny. Well, let me run it again. Let's see if it works. Yeah, that might be it. At any rate, it lets you go and modify the code inline, and it doesn't have all the app or the bit rate, codec, all that stuff. So if you want it, you can certainly add it in through the constraints object, but it lets you mess with that inline and see what your changes are right there. And then we also have one for playback. Just of note, there's a lot of overhead kind of with the SDP munging, basically setting the codec to work with different browsers based on what the client is. And that composes quite a few lines of code on this. So that's really the bulk of it. But that's something that we have in this GitHub file right here. So you could just link that in and then make sure all your method names match up with that, and all your peer connection and WebSocket stuff that you get from here could be much more simplified. So you don't have to include all the lines in here. That's pretty much everything I have, Amar. I'm gonna hand it back to you.
All right. So we're, 1 for 2 on the demo gods. It's pretty good. Let me get my PowerPoint back up here. Like Drew mentioned, we did just kind of launch this code pen experience. So we're working on building that out. Both of those pens should be publicly available at this point. After this webinar, though, I'll go back and double check to make sure those are available. We have a team. It's in the process of getting a Wowza logo. Ran into some bugs there with their platform. But if you're looking for this and potentially any future JavaScript-based examples, you can go to codepen.io/team/Wowza and be able to find what we're working on there. And we'll double check to make sure that these are working and running for you to kind of play around with.
I actually just refreshed the page and it works. I think it was because they switched over. So my bad.
Of course. No, that's my bad too. I was like, if I just do this behind the scenes, will it work? Apparently not. So links to both the CodePen examples and our GitHub examples. So Drew referenced a couple of files in the WebRTC examples repo. Those are available for you to kind of play around with and look at. The big asterisk that I always put on this is these are a set of examples. So it's an implementation, a way to go about making your player and publisher work with WebRTC and Wowza. So customize it, tweak it, let us know how you're building things, but please don't just throw these into production. You need some additional work around that. So I've been taking a peek at some of the questions here. Let me just double check to see if we have any that are relevant to answer right now before we continue moving forward. I do see one about, are you working with popular players so that your WebRTC streams are supported directly or through plugin, referencing Video.js, JW Player, etc. Within WebRTC, I don't think we're working with any players currently. With some of our other workflows and protocols, we are working with other players. I don't know, Frank, if you have any more on that one.
I think our focus now certainly is on our players. I'm not sure if Video.js or JW Player do have a WebRTC plugin, but I do know that for that to be created, it would require integration with our methodology of doing signaling, which I'm actually going to be going over very shortly.
Oh my gosh, another great segue. Very cool. Okay. So with that, Frank, you want to tell us about signaling?
Sure. So just to take a step back, one of the reasons we had to create our publisher and player pages is because we needed a way for Wowza Streaming Engine or clients to connect to browser WebRTC implementations in the browser to connect to Wowza Streaming Engine. The data we needed to share between these browsers in Wowza Streaming Engine to create an actual connection to send media is standardized, but the means to actually exchange data to get that connection created and the browsers in the server connected is not. All of our data that we do exchange for signaling is sent over a WebSocket connection, where Wowza Streaming Engine is configured as a WebSocket server. In our example pages, JavaScript is creating WebSocket clients to send and receive data to set up connections to support the delivery of the media. Other servers sometimes choose, and even Engine could have chosen to do this with vanilla HTTP with REST-like commands, but we believe that a persistent, secure WebSocket connection would provide the most flexible and simple medium to do signaling, and it is certainly widely supported against our target clients that we are interoperable with, which is the browser. In case you didn't know, this signaling connection is not something we transport media over. Instead, media is sent over RTP connections. That's certainly covered in the first video and is well documented on the internet. So just to go back and define signaling in particular WebRTC is really defined as a means to connect machines to each other and to agree upon what they are going to send to each other. With WebRTC, we're going to be sending media, and typically in WebRTC, you may see this typically being defined as a way to connect to people directly in a web browser with something like a video chat application. For this to happen, generally with WebRTC, you need a signaling server to make this work to get around network traversal issues. The picture depicted on the left left part of this slide up here shows the laptop kind of being the signaling server and the browser logos being the clients connecting to each other. In this particular instance, you'll see that the signaling server here is helping negotiate what media is going to be sent between them. It's going to help the two clients connect, but the initial connection, which is where, or the resultant connection that will be sending the media, is not being sent to the signaling server, but directly from one browser to another. With Wowza Streaming Engine, we act as the signaling server, but we also act as the remote endpoint for both the publishing and playback clients media. This means that actions to connect to publishing and playback clients together are independent by default by Wowza Streaming Engine. For example, a typical workflow can involve having a publishing client request to Wowza Streaming Engine to send in audio and video from a microphone and camera identified by the browser and selected by our example pages, just like Drew showed earlier. Once the connection for this media has been established to Wowza Streaming Engine and the media is flowing to the server, a playback client could then request access to play this stream and play it back in their browser. Due to this nature, I think that this kind of flexible anything in, anything out architecture that Engine supports can allow customers to flexibly create ways to do authentication and access control for publishing and playback clients with WebRTC with different restrictions if it's important to their workflow. And that's something we will be talking on later. Amar, could you bring us to the next slide?
Sure thing. I'm just looking, we're getting questions from Facebook and a couple of other places as well. Our team behind the scenes is doing a really good job at displaying some of that. Would now be a good time to talk about stun and turn servers and how that fits with Wowza. We have a question about, does Wowza serve as a stun server through WSS link?
Sure. Yeah, and the answer to that is the WebSocket link does not act as the stun server. That is done through our ICE candidate addresses that we send. Once a client then takes that ICE candidate and then attempts to connect to it, Engine will act as a stun server, allowing for capabilities to traverse symmetric NATs.
All right, I'll let you continue with more signaling.
All right, so I briefly touched on this a little bit, but another benefit of having Wowza Streaming act as both the signaling server and the endpoint that receives and sends the media is that it allows customers to utilize Wowza Streaming Engine's abundance of other tools to deliver media over networks. For example, a customer could use WebRTC to publish in to Wowza Streaming Engine and then choose to deliver multiple renditions of the same content transcoded using ageless ABR technology to viewers. In addition to also offering real-time latency streams for with WebRTC if they choose to do so. Customers can, of course, flexibly ingest other supported protocols into Wowza Streaming Engine and deliver media with WebRTC to playback clients, and we have an abundance of documentation on this subject. All right, on to the next slide. So here I figured I'd go ahead and try and cover a couple of the big things that happens with signaling and how they're important with Engine. In particular, because like I said, this is the part of the specification that is kind of left undefined. And I'm going to go over how we exchange the data between our browser clients and server. But an important piece of most use cases for Wowza Streaming Engine that we support across most of our protocols is focused on security and authentication, which must be done through this signaling connection. So overall, the three things that I'd like to call out that are big subjects for signaling mechanics are going to be ICE, SDP, and this security and authentication. But to start with ICE, this stands for interactive connectivity establishment, and ICE is used to deliver IP addresses, ports, and selected of TCP or UDP as a transport protocol to clients to try and make those connections between WebRTC capable machines. This is configured in Wowza Streaming Engine through the application XML and through the manager. And other than that, like it's kind of transparent to what, it's kind of a transparent thing. The only time customers really need to edit this is to ensure that they are advertising a public IP address that is accessible over the public internet or the network they want clients to be able to connect to. SDP stands for a Session Description Protocol. It is a format for describing multimedia communication sessions for the purposes of session announcement and session invitation. And it is, like Drew said, a larger piece of some of our JavaScript code, and is the one of the primary pieces of data we're exchanging between the client and server to create connections. More on SDP in the next slides with you, Amara.
Cool. Let me ask you a couple of questions before we dive into that. One of the questions was, when WebRTC degrades, is it typically because CPU, whether that's server side or client side, latency, bandwidth or congestion, or some other reason?
It could be any of those. So congestion control and bandwidth are kind of related to each other. In general, like if in between a publishing client and a server, we are noticing that packets are being dropped, that the stream is unhealthy, the browser will drop the bit rate. So the quality of the stream will degrade. The browser tends to make the best decisions about how to do that. So that is certainly something that isn't offered by many other publishing encoders, and is certainly something that's good to take advantage of. So in the end, you know, when WebRTC degrades, it could be because of any of those three or a combination.
I think I'd like to add too, on the client side, kind of what I've typically been seeing, and that came up a little bit in my demo, was the client CPU was the bottleneck, and so that caused a degradation. But in like the instance of if you're trying to implement a chat app or a meeting app through Streaming Engine, then you're more likely to see that issue on the server than the client.
That's actually a good point. And another similar question, when somebody asked, we noticed significant CPU usage by Wowza Streaming Engine when multiple WebRTC sessions happen simultaneously. Is CPU power going to be a bottleneck resource, just like network bandwidth?
It could be. I mean, especially if you're transcoding, you know, transcoding is a CPU intensive operation. So I think that it's important to understand what you're doing and the effects of it on the servers you're going to be deploying.
Yeah, I think that the key takeaway here too is understanding the difference between the client side and the server side, where you're seeing those issues and how you potentially want to address those issues. Okay, so I know we've got some other questions. I'm going to move on to the next slide and see if we can slot those in a little bit better with our upcoming topics. So one of the things that I wanted to cover was actually a suggestion from Frank, was around what those SDP offer answers look like. Within our client-side code, especially our GitHub examples, if you open a browser inspector, you take a look at some of the information that we have displayed, you can see these offer answers in action on the client side. One of the things that I like to talk about with this offer answer kind of handshake display, it's not a negotiation. I think that's one of the things that I've had kind of a hard time training myself out of, saying it's a negotiation, because really it's a display of what is possible, not a compromise. There's no negotiation happening between the client and the server. So if you look at our published example for existence, and again, these are available out on GitHub. We'll show another link a little bit later in this presentation. But you should see, if you're successful in executing a a WebRTC publish, you'll see 3 SDPs. The first one is going to be quite verbose, and you'll see that it displays everything that's supported in that particular browser. So you'll see a lot of different information around the different video codecs. As far as audio is concerned, it's just Opus, but you'll see information about that. But you'll see a lot of information in there. Some of it will be relevant to the choices that you make in that connection, some of them not so much. From there, you'll see a second SDP, and this is what you've chosen to publish with. So when Drew was showing the UI where it goes through and you can choose your video codec, again, your audio codec is going to be Opus. You can change some of the additional parameters there too. You will see that that's information that's passed along in that next SDP object. Finally, the last one, the third one in our published scenario is what is supported in Engine. So theoretically, this is where everything should look like it matches if it's going to be successful. A lot of the times, if we do see failures, it happens between the second and the third SDP. So you can see in the browser inspector, that's potentially where you'll see errors. It'll give you a little bit more information about how to go about debugging that. The way that I've kind of written this particular slide is WebRTC to WebRTC. But if you have other protocols that you're using, maybe you're doing non-WebRTC ingest, and you're looking at the output, you may have to do a little bit of work on the JavaScript side to munge the SDP in such a way that it will play back successfully. We're not going to get into a ton of that here today, but I did want to mention if you want to kind of like nerd out over what's happening in the inspector, that gives you a little bit better understanding of what you should see, particularly if you're successful there. On the playback side of things, there is one SDP that you should see, and it's basically here's what's coming from Engine. And there's some really good resources if you Google like SDP anatomy, that'll walk you through each of the individual lines and can give you some more information about what you should see or what you are seeing on each of those lines in an SDP, what is potentially something that you could munge and you can change, and what are things that you probably shouldn't change if you want to have a successful connection. But I would take a look at that and see, you know, are there things that you're doing or you're trying to do, and maybe there's ways that you can do some of that JavaScript munging to get a better outcome. But if you take away anything from this slide, I would say it is not a negotiation. There's no compromise that's made between the server and the client. It's just an exchange of here is what I can do, or here is what I am offering, whether it's playback or publish, and it's either going to be successful or not. So a quick screenshot. And again, if you're playing around with our example code, you're able to go into browser of your choice and run the relevant inspector there. This first one is on the publish side. This is that third SDP object. So you can see it's telling you it's originating from Streaming Engine. I'm running this locally when I ran this last night to grab this screenshot. And it goes through and reflects all of the choices that I would like to have. So there's Opus audio, it's H.264 video. Again, there's resources online where you can kind of walk through and learn a little bit more about what is going on with these SDP objects. The other one that I wanted to show was on the playback side, what that looks like. Again, this is originating from Wowza's streaming engine because it's going to be delivering the stream or delivering the audio and video to the browser client. And again, this is showing the information about what that looks like. So Frank, I know this is your slide. Before we get to this, I do want to run another poll. So if Justin, you want to pull that poll up for our viewers so that they can get that answered, and we can continue on with the WebSocket message structure. Thank you. All right, Frank, you want to take it away?
Sure. So just before going over the actual message structure, I wanted to go over the 3 big things people will typically do or interact with Wowza streaming engine with when they're working with their clients that drive these kind of messages and how they're separated into different commands above. One thing customers may want to do would be to publish media. Another would be to play media back from a server. And the third thing a customer would want to do would be to query the server to see if there are streams available for playback. When we look at the different commands that are enumerated inside of that message structure, the send offer is what the browser uses to send the SDP to us, which we will respond to with what media we will accept, just as outlined by Amara. The get offer and send response messages or commands above are used for players to ask WC to send details about what media it can send to playback clients. And then we have lastly, get available streams, which is available to ask engine what media streams are currently available, along with some additional information on an application or an application instance inside of Wowza streaming engine. To access these types of commands, you can turn off access control or make these commands usable or non-usable on a per application basis. It's probably the simplest form of access control you can do for a server. You can this is almost turning on or off ingest and egress of WebRTC for the server. The next piece of data inside this message structure is the stream info. If you are a Wowza veteran, some of this probably is familiar to you. You see the application name and the stream name, and this data is what is commonly used to uniquely identify a stream and kind of group them into Wowza streaming engine's hierarchy of configurations. There's also a direction flag there, which lets the server know whether or not the action is coming from a publisher or playback client. And lastly is the SDP payload, which is primary piece of information we're looking to exchange. And most importantly, for the purpose of going over a bit of this, is the user data fields above also. These are optional. You do not have to fill out data inside of these, but user data key value or JSON data could be embedded inside of that JSON structure so that a customer could send authentication or access control data to a server. And lastly, but not depicted, I didn't include any of the response messages to these, but our response messages typically also include information like a status code to indicate whether or not a request has succeeded or failed, and these kind of map to HTTP status codes, and also a plain text status description to give you more human readable indication as to why something succeeded or failed. And other messages that also go across are the ICE candidate addresses. On to the next slide. So now that we kind of understand this basic message structure, you can begin to see how we're connecting the client in the server or transmitting data from the client to the server to allow for access control. Looking at the article linked in this page, anyone could see how somebody might be able to get the data out of the user data JSON structure or additional data sent to the server over WebSocket connection that could be used to perform access control. To find out how to send this data over the WebSocket connection to Wowza streaming engine, I would encourage you to go to our example pages repository and look for user data. It is inside of the publisher and player JavaScript files. You can see where we encode and send WebSocket messages and where it is. And that might be where you would choose to add data to create, to implement access control for your applications. Other options to find the article above about how you could provide information for authentication include using a querying component in the signaling URL that you're using, and how that can also be used to, allow or deny publishing, playback, or querying of streams.
So we do have a question. I know we're going to get into UDP and TCP here, probably the next slide. But I was going to say it's not a question, it's a statement. Sorry. Connectivity issues with UDP in users behind VPN or network firewalls. Any suggestion on how to handle those would be great. Is that something that you can kind of talk about? I feel like this is maybe a better conversation for one of our sales engineers to maybe take and dig into a little bit more, but is there anything that you'd want to touch on, Frank?
Yeah, I think that, when dealing with network firewalls or VPNs, the first suggestion I would look at to handle that would be to make sure that you are using a symmetric NAT. Like, the important thing when hosting your Wowza streaming engine WebRTC server is that you need to be sure that the client that is connecting to the Wowza streaming engine server is able to directly connect to that streaming engine server. So if your network prevents that for the WebSocket connection, you're not even going to be able to start. If your network prevents you from creating UDP connections, or the network file stops those, you're going to have to turn off or use TCP to get around that. And you're also going to have to make sure that your networks and firewalls have ports open for the port ranges we use for TCP and UDP. I think by default, I can't remember exactly, maybe it's 6790 to 7,000 ports are open for UDP, and by default we do TCP WebSocket connections over 1935, but this stuff can all be tuned and is documented in some of our setup guides.
Yeah, I always have to look it up. People ask me about the ports all the time. I'm like, I don't remember the port ranges. All right, so Frank, take us through TCP and UDP.
Sure. So the debate between using TCP and UDP is generally focused around choosing reliability versus timeliness for the media you're sending over a network. So we choose UDP, or we recommend it, because it is faster and your media streams are able to recover from interruptions relatively easily. RTP and RTCP allow for error recovery and resiliency with UDP without the overhead of TCP congestion control and more aggressive resiliency mechanisms focused on in-order delivery. Some of those mechanisms may introduce, manifest themselves as, direct additions to latency in your stream that are difficult to catch up, perform like a catch-up operation on, or something like that. And for rate control of outbound playback delivery. So you may need to choose TCP to get around networking issues. If your network doesn't allow UDP traffic, we kind of just went over, or if you can't open up or maintain firewall port ranges to do the UDP streaming, but we do recommend UDP.
All right. So I know I mentioned a couple of times in answering questions or offering support to answer some questions that we were going to show the links for our GitHub examples, our CodePen examples, and some other interesting things for folks. That is this slide. We will also send the slide out to, I believe, anyone who registered, or it's all of the slides. So you'll have that available to you as well. But of course, you could take a screenshot. I think most of these are pretty human readable. If you want to type them in, kind of click around. But this is our last slide for our webinar today. So I'm going to kind of briefly pause here. I know we do have some other questions coming in. So if you've got a question that you wanted to ask, please get that over to us at this point so that we can figure out, do we answer it now or do we send you resources and link you to other folks later? There are a couple of questions that I've seen around, I need low latency for live events on the production input side, not the consumer viewer side. I don't know if we're the best to kind of talk through that. I think we would need to drill in a little bit more about what you're trying to do. So it's not a non-answer, but I would recommend reaching out so we can put you in touch with somebody on the sales side that can talk a little bit more about what you're trying to do and what customers who are currently working with us, what they are doing in that space. Okay, so we've got some questions coming in. Apologize in advance. I'm doing a lot of multitasking here. So looks like a client side question. What are the best camera clients that support WebRTC and UDP in particular for each platform, Android, iOS, web/browser?
So as far as iOS goes, Safari is pretty much the only thing that works on that, and that's an Apple limitation. We generally do most of our browser testing with Chrome, but Firefox also and Safari also work as well. I personally haven't done anything with Edge or IE.
It supports pretty much anything that's like plug and playable on your operating system, right?
Yeah, and it's got to be fairly modern. Supports HTML5 standard and all that. So
cool, thank you.
Yeah,
we have another one.
7 users.
No, it's okay. I think that's the other thing too. I know when we have questions that come in through either the community forums or through our Slack instance, we get a lot of those, how do I make this work on this particular device with this particular constraints? And it really depends. And I think the big takeaway for me is just because it works on Chrome on your desktop doesn't mean it's going to work on Chrome on your iOS device, which is a difficult conversation to have with someone who's like, but it's still Chrome. So we got some other questions here. Are there any chat room / text-based components that you'd recommend to implement with a WebRTC player for client side, ideally for a live auction use to allow bidders to type in their bids?
That's a pretty specific ask. I know WebRTCHacks.com has an example of how to implement like a chat example, and we are doing meeting examples that'll go out on our GitHub here in the next few weeks or so. But that's definitely something that you'd probably have to roll your own at this point, using examples that are found.
Right, that was going to be my recommendation. Is I think previously, not necessarily in the context of WebRTC, but we've had, I believe the company's name is Stream.io. They have an example that they've built with using a Wowza stream in a player on a web page where they've included like a chat room text-based functionality. They're not necessarily the only ones. They are just an option that approached Wowza and said, hey, if your customers are looking for something like this. But especially in terms of live auction, I think, unfortunately, we kind of have is you're going to want that to be as near real time as possible if you're going to allow bidders to type in their bids. So it's not a non-answer, but it's close. And Frank, I don't know if you had anything to add there.
Yeah, one of the things I would look to first if I were looking to implement a text-based or real-time messaging between the clients would be to just use the WebSocket connections that are already available, to each of the publisher and playback clients. But keeping those open and ensuring you're doing this all correctly is certainly going to be on the developer undergoing this.
Right. So don't really have a great recommendation there, and it's not something that's on our roadmap to implement either. Looking through some of the other places that we've got folks asking questions, it looks like we've kind of slowed down a little bit. So I wanted to kind of walk through these resources really quickly. Our Wowza developer links will give you access to our WebRTC page that's out on the developer portal, which kind of brings all of our WebRTC resources for developers together. It will also link you to our GitHub examples, our hosted pages if you want to get started with that. We also have our community. Like I mentioned, we've got a WebRTC tag where we're actively answering questions and discussing WebRTC solutions there. The two that I've kind of hinted at throughout this entire webinar are the GitHub examples, the CodePad examples that Drew shared. Both of those. Those are available to you to play around with, hack, use in your own solutions and implement in your own ways. And then for any of these, if you want to actually trial WebRTC, we have links down at the bottom to both our Wowza Streaming Engine developer trial and our cloud trial. I know we didn't talk a lot about cloud today. We do have the ability there to do WebRTC publish and then HLS playback. So if you remember the chart that I showed at kind of the beginning of this webinar, it walks through that workflow if you're interested in that. We do have a couple other questions. Let me kind of skim them really quick to see if we should answer them or wrap up. Let's see. New to WebRTC, trying to understand how ICE and SDP work along to get WebRTC working. Which one is sent first and how does Wowza Streaming Engine take care of it? Basically, what is the workflow that Wowza Streaming Engine takes care to start media transfer for WebRTC? So I think we touched on this kind of midway through the presentation where we talked about how there's a client side and server side exchange of information with the SDP objects. So I don't know if you missed that. So I would say when we have this available as a recording to kind of go back and take a look at that, as well as our documentation resources that kind of explain what's happening there. I don't know, Frank, I feel like that's such a meaty topic to go through towards the end of this webinar, but is there anything else that you wanted to point out or maybe a good documentation article for that person to reference?
Yeah, I certainly have a couple, not off the top of my head, but in general, yeah, like the biggest things that happen are the SDP is exchanged, and then we use ICE to actually, connect the clients for the media streams. So there's really, two stages of messages that go on there. One being exchanging of SDP, and then doing ICE to exchange the information to set up the underlying connections to send the WebRTC based media.
Okay, I guess Frank and Drew, do you want to take a look at the questions and see if there's any that you'd like to cover? I know we're going to need to wrap up here.
Yeah, so there's from Simon, the WebRTC demo requires the user to press the play button to consume a stream. If that stream is another WebRTC, then you can't play until you've published. Is there a way to automate that so that the player auto starts? What I would recommend doing is establishing a WebSocket connection to Streaming Engine and then querying for the available streams. And once you see there is one, then populating your user media with that and playing it back.
Sounds good.
There is a question here stating, is there a guide for suggested server setup for best real-time settings? I do believe that we have some of that information in our setup guide. If not, the one thing that you're going to want to make sure to tune would be to tune your transcoder template. I think the default one works fairly well and is WebRTC compatible from what we've seen. And you can also set your application type to a low latency application. Those could be two things to look at for ensuring best real-time settings. And the assumption that using the player will take care of most of this signaling is true, and that is why we provide it.
All right. And then the last question that I'm seeing here, can your Wowza cloud support custom ingest Java to push content to AI pathways? I'm not entirely sure how to answer that one. We have a Wowza Streaming Cloud REST API that you could interact with, but as far as supporting custom ingest Java, I'm not really understanding that. Well, all right. It looks like we are out of questions, which is perfect because we need to wrap up anyway. Frank, Drew, thank you so much for joining me and walking through this 102 level content. Do you have any final comments or things that you want to leave folks with on our way out?
Thanks for having me.
Yeah, thanks for having us, and thanks everybody for joining along as we all go on this WebRTC journey.
All right, thanks everyone. Have a great rest of your day.